Okay. I think this is approximately where we had left off. Is that correct? We're a little behind. Okay. All right. So with this tomorrow, yes, I will not be in here. We'll have short answers for you to work on. Like for instance, one question would be, we've talked about simple microscopes, but we talked about more complex types. There are three types of those electron microscopes. One of them is tunneling, one of them is scanning, and the other one's transmission electron microscopes. So, for instance, describe what the differences are of each, and why is a tunneling electron microscope significant? Well, if I'm not mistaken, I believe you can view live organisms, where the other two, they are dead. You can see genetic material with the tunneling electron microscope. I believe questions like that. So if you have these filled out, you will be doing yourself a favor, okay? And you might be saying, this content is so boring. Well, I'm not going to agree with it, or I am going to agree with you, but we want you to have a good background of this, because it is on the standardized tests, this content is, okay? So hopefully we can see the reason. A reason is a valid one, or the validity in this content. Okay, we just going to remember this, or? Okay, it's recording right now. You can do that too. Okay. Well, that's for people who are not here. Okay. So, going back to the function of these cells. If you talk about cell division, these centrioles here, they grab the chromosomes and separate them. Because does anyone know, I've got a job, I'm just trying to do it, okay? Maybe if a guy can't do his job, maybe he doesn't have one. I don't know. Does that sound accurate? Or just because it's hot in here, it's the last period of the day, we don't want to be here. But I want you to think about this. If this is the toughest part of what you had to experience so far, what's it going to be like when you're out on your own? Okay? Trust me, we all want you to be successful. Okay? And maybe it's just a matter of perception. We are trying to improve your ability to learn. And the quicker we get this started, the quicker we get done, and I don't have to stop and say, come on, people. All right? So, does anyone know what's on the chromosomes? They are in the nucleus. So what do we know about the nucleus other than being in the approximate center of the cell? What does it control? Yeah, the cellular activities within that cell. And that's encoded on these three letters. It's an abbreviation for a really long word. Well, I call it deoxyribonucleic acid, but you can call it DNA. Okay? So what happens is that DNA is coiled around chromosomes. So when these cells divide, that has the information or coded on them. That's how a lot of this stuff is interconnected or linked together, and why it's important. Okay? And for instance, something like this, okay? Helps us in our lymphatic system, because some of you, maybe on the volleyball court, football field, I've tripped in marching band before, and did I say the basketball, volleyball court, whichever. If you break your skin open, okay, how do you keep that debris from getting inside your bloodstream? Well, sometimes your lymphatic system will do that for you. Or different types of structures like these that will break down bacteria and viruses that may enter the cell. But when you're talking about rubbing on your elbow, that's really thick substance, okay, that's called lymph. That's why it's called part of the lymphatic system. All right. So as you're writing this down about what mitochondria are and what they do, I want you to think about where you might find something like that. And the clue is this. Okay? Okay. So where do you think is a place in the human body that really needs a lot of energy? Now, there's certain places, your ears. Do you need a lot of energy in your ears? No, you do not. And one aspect that we could illustrate to prove that is, I will look at some of the guys' ears, but it's mainly tailored towards the women. Just walking around, what would I be looking for? Ear piercing. You just say piercings or ears, whichever. You get the idea. So, I see some holes there. Okay, so why is it you would not need a lot of energy, hence no or very few mitochondria in your ears? What happens when you get your ears pierced? Does it bleed? No, it does not. So it has very little blood supply there. So with that being said, it's not going to require a lot of energy because it's cartilage. Cartilage is something that's called avascular. That's why it might hurt a little bit, but usually I think that gun they use just shoots it so fast that probably don't even feel it, right? Or I think some people, if you wanted to, you could just put ice on there and stick a needle through it and you probably don't even feel it. Okay? So places, nose, joints, ears, like your knee joint, those are all made of cartilage, so there's not going to be very many mitochondria there. But where is there a place that really consumes a lot of energy? The brain is one. The heart is a muscle. You could say in your chest, your diaphragm as well. Those muscles have to have lots of mitochondria in there. How many of you during even volleyball practice, you do some running in volleyball, right? Were any of your legs sore at all? Okay. Guys, in football, do we do a little running in there? Okay. Or if we are working at a job, when you're using the same muscles over and over again, it's possible for them to get sore. And what's happening is you don't have enough mitochondria. What happened to poor George on the treadmill? Why did he fall off? One of the things they illustrated in that video, that educational video, we hope, okay, approximately how many mitochondria did he have in his muscle cells? Not enough, maybe 1, 2. What would happen is that transformation that takes place, your body becomes more efficient. Then the next time you did that running, it probably didn't seem as bad, did it? That's because you're getting more of these. These start to divide as well. Okay? And when they do that, you're just producing more energy. And your body's becoming more efficient as well. You're not burning as much, let's say, you're burning more sugar as opposed to glycogen, which is a type of sugar. You just you're doing this too because you're breathing heavy because all the oxygen is going to your brain and your heart and your diaphragm, which it has to because that's what requires the most energy. Then probably your large leg muscles where it starts to get a little sore. Heck, even myself, during cross-country practice, I still get really, really sore. But I'm old. I don't know. But maybe age is just a number. I don't know. Could be, maybe, maybe not. We do what we can. Okay. Now, we got to be getting close to the end of what your paper that you have, I would think. That's it? Yes. Yes. So, even though there might be more material here, you have to have that handed out to you. I've got that done. I just got to transfer it over into PowerPoint so we can talk about it. Tomorrow, we will be talking about, tomorrow I have those short answers. Like, what was one of the questions I already gave you a hint towards? What about microscopes? I know, there's really simple light microscopes, but then maybe at some point they'll get rid of me and save money, and then Mr. Williamson can have his electron microscope. They're not going to pay me $500,000 and then you get your scanning electron microscope. That's probably about how much it is. But yes, even if you were paying attention to that, you probably could help yourself out, have one of those answered already because it could be kind of confusing. But the information is in the materials in front of you. For those of you who make a choice to, 1, write it down, 2, to listen. But then, of course, that's everybody in here, right? Yep. Yeah, of course. Okay, so that will be for you tomorrow. So that's all I've got. We'll catch up to you next time. All right.